Our goal is to show that function y, which is e to power 3x times the integral e to power negative 3t divided by t dt, is indeed a solution for the first order differential equation xy prime minus 3xy equal to 1. What are you going to do? You're going to plug in y and then take the derivative of y, plug that in here, and show that when you do the subtraction on the left-hand side, the subtraction is equal to 1. We have y, we need to find the derivative of y as well. So let us write this down. And we need to find the derivative of y and then do the substitution. Our y is equal to e to power 3x times the integral e to power negative 3t divided by t dt. T is changing between 1 to x. So as you can see, it's a multiplication of two things. It means that to find a derivative, we have to apply the product rule. If y is equal to f times g, when you're taking the derivative of y, it is f prime g plus f g prime. You're doing the same thing here. The derivative of e to power 3x times the integral plus e to 3x times the derivative of this integral. Let us begin, everybody. So y prime is equal to the derivative of e to power 3x times the integral 1 to x e to power negative 3t divided by t dt plus e to power 3x times the derivative of the integral. The first derivative is very easy. Applying chain rule, you get 3 e to power 3x times the integral 1 to x e to power negative 3t divided by t dt. For the derivative of the integral, you're going to apply the fundamental theorem of calculus. So copy down e to power 3x, which is coming here, and then the derivative of this integral is the derivative of x, which is 1, times e to power negative 3x divided by x. So this is our derivative. But take a look at our differential equation. The differential equation that you're having is x y prime minus 3xy, and it's on the right-hand side equal to 1. We need to plug in y, we need to plug in y prime, and do the algebra on the left-hand side. I'm going to copy down x. My y prime is the whole quantity here. I can simplify this further as well, because e to power 3x times e to power negative 3x, it's equal to 1. So this quantity on the left-hand side is x y prime, which becomes x times 3 e to 3x, the integral 1 to x e to power negative 3t divided by t dt plus 1 over x minus 3x times y, but we know that y is equal to, take a look at your y, e to power 3x times the integral of 1 to x e to power negative 3t divided by t dt. So here we have e to power 3x, the integral 1 to x e to power negative 3t divided by t dt. Is this equal to 1? This is our goal. We want to show that this guy becomes 1. Let's put a question mark on top of it. So on the left-hand side, if you distribute x into parentheses, it becomes x times 3 e to power 3x integral 1 to x e to power negative 3t divided by t dt plus x divided by x is nothing but 1 minus 3x e to power 3x integral 1 to x e to power negative 3t divided by t dt. But obviously, these two are opposite of each other. So it gets canceled out. What's left? 1 is left on the left-hand side, which indeed is equal to 1 on the right-hand side. So what is our conclusion? Our conclusion is y equals to e to power 3x times, has a 3 next to it as well, okay, integral 1 to x e to power negative 3t divided by t dt is a solution of the first order differential equation xy prime minus 3xy equals to 1. So let us recap what we did. We had a function y equals to e to power 3x integral e to power negative 3t divided by t dt. We wanted to show that this is indeed a solution for the first order differential equation xy prime minus 3xy equals to 1. All you needed to do is to find the derivative of y applying the product rule. Then basically do the substitution in the left-hand side of the differential equation. After simplifying it, you could see that left-hand side and right-hand side are equal to each other. Since left-hand side and right-hand side are equal to each other, it means that you have indeed a solution for a differential equation. I know this solution is not a typical solution. It's given in the form of an integral. Sometimes some integrals are a little bit difficult to calculate. So we have to leave them as they are and represent them as a solution for the differential equation. It's not unusual in solving a differential equation to have some solutions in this format.